Hi guys. Today we are going to be talking about matter. So what is matter? Matter is anything that has mass and takes up space. Okay, so the three most common states of matter, which I'm betting you probably already know, you just didn't realize that they were states of matter, are solid, liquid, and gas. So, mass and volume. So remember, matter is anything that has mass and takes up space. Mass is the amount of matter that an object has. Okay? Volume is how much space that object takes up. For example, okay, I have a basketball and I have a soccer ball. They're about the same size, so they take up about the same amount of space. Okay? But one of them has more mass than the other one. One of them would hurt more to drop on my foot than the other one. Okay? The basketball has more mass. So even though they have about the same volume, okay, the basketball has more mass than the soccer ball. Okay, so what is matter made of? Okay, because if it's all around us, which it is, then it has to be made of something. Okay, so matter is made of molecules. Okay, molecules are so small you can't even see them with the naked eye. Even if I zoomed in as much as I possibly could on the camera, you still wouldn't be able to see molecules. Molecules are made up of tiny atoms, and atoms are even smaller than molecules, so you can't see them either. For example, we have a standard sheet of paper. Just one, not a whole pack, just one piece of paper is made up of about 1,000,000 atoms. A million atoms thick. I mean, look at that. It's not very thick at all, but it's 1,000,000 atoms thick. That's how small atoms are. So these molecules, they are packed differently or formed differently in solids, liquids, and gases. In solids, the molecules are so tightly packed together that the molecules on the inside, they can't move, okay? Like my sink here, okay? The molecules are so packed tight together that it stays in the same shape all the time, okay? Even if I took and I broke the sink, which I'm not going to do, one, because I'm not strong enough, and two, because Miss Clark, the principal, would not be very happy with me, okay? Even if I broke it, it would still be relatively the same shape, just in now two different pieces. All right? A liquid, like my Dr. Pepper on the inside, a liquid has some space between the molecules. Not a lot, but enough where it can move a little bit. So if I were to pour my Dr. Pepper into something, then it would take the shape of whatever I poured it into. Usually a cup. And then gas, there is so much space between the molecules that the molecules can just float around and do whatever their merry little selves want to. Okay, so solids are tightly packed. Liquids can move just a little bit. Gases are floating all over the place. So, first we're going to talk about solids. All right, solids are a type of matter that are hard and they have their own shape. Okay, this nice box of tissue, it's hard, right? If I tried to put it in this beaker here, it's not going to change its shape. All right, they have a definite mass, volume, and shape. Okay, so it doesn't change when I put it in here. Definite means that it does not change. So some examples of solids would be cars, or hats, most hats, or strawberries. Okay, so I have some ice here. Ice is an example of a solid, okay, because when I put the ice in the beaker, okay, I don't know if you can see that here, one second. There we go. When I put the ice in the beaker, it just kind of moves around a little bit. It doesn't take the shape of the beaker. It has a definite shape. Probably I got too much ice. All right. Ice is a solid because its molecules are packed super tight together. All right. And it's less dense than water. Okay, so this is water. It's purple water because I put food coloring in it, but it is water. So if I take my piece of ice, nope, not that one, my bad. My piece of ice, and I put it in the water, it floats. See, there's the ice right there. Oh, it keeps moving to the other side. Apparently it's camera shy. There we go. Okay, it floats. That means that the ice is less dense than the water because it is a solid. Liquids. Liquids do not have their own shape, but they take the shape of the container that they are put in. So, when I put the ice in here, it stayed ice. It stayed in the exact same shape. But when I take my purple water here and I pour it in the large beaker, okay, now it didn't stay this size. It didn't stay this shape, right? It changed shape to the larger beaker because its atoms aren't so tightly packed together that it can't move. Okay, so liquids have a definite mass and volume, so it's the same amount of water, okay? It has the same mass, but it does not have a definite shape. So some examples of liquids are juice, water, milk. Gases, okay? Gases do not have their own shape. They tend to just spread out, okay? Now, I don't know if you can see it, but here I have some boiling water, but you can definitely hear it if I put the lid down on my teapot. So teapots are designed with this fancy little lid right here, okay? And when the steam is forced through it, it whistles. Can be quite annoying. But it whistles so that it lets you know that the water inside is boiling and it's ready for the tea. All right? So, if I tried to catch some of this, see, it just came right out. I don't know if you can see that. Here, I'll try it on this side. Hold up. See, it just comes right out. It might have fogged up the lens, my bad, of the container. Okay? I can't keep it in the container. Okay? I could try to put a lid on it. I could try to put my hand on top, but it would still escape out of the side. Okay? Because gas do not have a definite mass, they do not have a definite shape, and they do not have a definite volume. They're just loose and floating all over the place. So some examples of gases are water vapor, helium, and propane. So, now we're going to talk about the difference between physical change and chemical change. A physical change is the change from one state to another. So remember, the states of matter that we're talking about are solids, liquids, and gases. Okay? So, a change in state, a change from one state to the other without changing the chemical composition. So, for example, this is a nice bucket of ice that I have. Okay? But from the time that I got it out of the ice machine and I started making the video, some of it melted. Look at that. I don't know if you can see it. Okay? It melted. It changed from a solid, the ice, to a liquid. But if we look at the molecules in it, okay, it's still 2 hydrogen, 1 oxygen, H2O. Okay? It's still water. It's just in a different state. It's the same thing with my teapot here. Okay? When I put the water in, it was in a liquid state. Okay? Now that it's boiling, it has changed into a gaseous state. You can see the water vapors coming up all around. All right? So there is no new substance that is formed. All right? Examples of physical change, like piece of paper, right? If I crumple this piece of paper up, now it's a crumpled piece of paper, but it's still a paper, right? So it's just physical changes that have happened to it, all right? Breaking a pencil. If you break a pencil, nothing chemically changes. It's still a pencil, you just have it in 2 pieces. Now, chemical changes, all right? Chemical changes result when a new substance is formed, all right? A gas is released. It cannot be reversed, all right? So, for example, this is a nice piece of paper that I'm going to tear smaller because if I set the fire alarms off, Miss Clark, the principal, is not going to be happy with me. All right, so if I take and I set this piece of paper on fire, I don't know if you can see that. I'll move closer. Okay, I set it on fire. That hurt. Now, we have a new substance. So, it was paper. Now, you see this black stuff on it has changed its chemical composition. This is a new substance. Oops. Oh. Okay. Now, you could also see smoke coming off of the piece of paper whenever I lit it on fire. Okay? That smoke was very different than this water vapor. This water vapor is just turning from a liquid state to a gaseous state. This water vapor, if you catch it, it can turn back into a liquid state. That's what happens when it rains, but we'll get there in like January. Okay? The smoke, on the other hand, that is an entirely new thing. Okay? I can't catch the smoke and then turn it back into a piece of paper. It does not work that way. All right, so some examples of chemical change are burning a candle or frying an egg in a pan. Once you've fried the egg, you cannot like put it back together in the eggshell and it be the same. Okay, it's changed forever. Or when nails rust, that rust on the outside of a nail, like that you hammer into something, you cannot, that is a new chemical, that is a new substance on the outside of the nail. All right, so here are the review questions that you are going to answer in your Google Classroom. Okay, what are the three states of matter? What is the difference between mass and volume? So remember when we talked about the soccer ball and the basketball, the difference between mass and volume. What is matter made of? True or false, solids have a definite mass, volume, and shape. True or false, liquids have their own shape. 6, what is one example of a gas? 7, is cutting wood, cutting it, just like cutting it, is that an example of a physical or a chemical change? And what is one example of a chemical change? That's all for today, guys.